Factoring quadratics review. Like I said, we're about to get into Chapter 4, Section 4, which is factoring polynomials that have a higher degree than 2. So, some of those same applications apply from factoring our quadratics, so that's why I wanted to do a review over factoring quadratics. So, step 1. We always check to see if there's a GCF, right? If there is a GCF, I want to factor that out first and foremost, right? So step 1, look for and factor out a GCF if there is one. Always look for it. There's not always going to be one, but always look for it first. Step 2, look at the number of terms to determine how to factor. A lot of times, how many terms there are will tell me how I need to factor it, right? So, if there's 2 terms, most of the time, if there's only 2 terms, I'm going to be using our special pattern called the difference of squares. Do you guys remember the difference of squares? Okay, if I have a squared minus b squared, so 2 things that I can take the square root of being subtracted, I can factor it like this. Take the square root of a squared. That'll give you a, and put it in the first position in each set of parentheses. Take the square root of b squared. That'll give you b. Put that in the second part of each set of parentheses. And then one's a plus, one's a minus. Does that somewhat ring a bell? That's our difference of squares. So here's an example with actual numbers. Can I take the square root of 4x squared? Yes, I can. Can I take the square root of 81? Yes, I can. Are they being subtracted? Yes, so this is a difference of squares. So I can create my 2 sets of parentheses.
Oh, not this stuff.
What's the square root of 4x squared? 2x. So I put 2x here as well as here. Now I take the square root of 81. What's the square root of 81? 9. So I put 9 here, 9 here. 1 gets a plus, 1 gets a minus. It's factored. Everyone got the difference of squares? Not too bad? Okay. If there's 3 terms, this is where we create our t-chart. If my leading coefficient is 1, I don't have to use slide and divide, do I? But if my leading coefficient is a number greater than 1, and I can't factor out a GCF, I'm going to have to end up sliding and dividing, right? Yeah. So let's look at one with a leading coefficient of 1. There's a number 1 in front of x squared, right? Do I have to slide and divide? No, I can jump straight to creating my sets of parentheses. What's the variable I'm using? X. And if I have a plus sign in front of my c value, does that tell me the signs are going to be the same or opposite? Same. Since they're going to be the same, this tells me what they're going to be. What are they both going to be? They're both going to be pluses. And now I can create my t-chart. What goes in this bigger space to the left on my t-chart? 30. My c value, right? And what goes in the smaller space? 13. So I'm looking for 2 numbers. I'm looking for 2 numbers that multiply to give me 30. Add to give me 13. So I can list factors of 30 here. What are 2 numbers that multiply to give me 30?
10 and 3.
10 and 3. Let's add 10 and 3. What's 10 plus 3? 13. Are those the 2 numbers I'm looking for? Yep. They multiply to give me 30. Add to give me 13. So I can fill in 10 right here, 3 right here. Is that factor now? Yeah. Yes, it is. We're okay with that example. Let's look at another one. Do I have a leading coefficient of 1? No. What's my leading coefficient? 2. Well, let's see if we can factor out a GCF. Is there a GCF out of these 3 terms that I can factor out? No. So which method am I going to have to use here? Slide and divide. Slide my 2 over, multiply it by my c value. So 6 in this case. y squared minus 7y. And what's 2 times 6? 12. Now I can just factor like I did over here. Using my t-chart, right? What variable are we using? Y. What's the sign in front of my c value? Plus. So the sign's going to be same or different? Same. Since they're going to be the same, what are they both going to be? Minus. Subtraction. We okay with that? Determining our signs. Now I can create my t-chart. Put my c value in the first space, my b value in the second space. So I want two numbers that multiply to give me positive 12, add to give me negative 7. What are two numbers that multiply to give me 12?
6 and 2.
6 and 2.
Oh, wait.
What's 6 plus 2?
12. Oh, wait.
8. Very good. Are those the two numbers I'm wanting? No. What are two other numbers that multiply to give me 12? Negative 3 and positive 4? That would give me negative 12. Negative 3 and negative 4. What's negative 3 plus negative 4? Negative 7. Are those the two numbers I'm wanting? Huh?
Yes.
These are not the numbers I'm wanting?
I know. They are.
They are.
Attorney, what smoke are you talking about?
Okay. So is that my answer? Is it factored now? What do I need to do? Very good. It's called slide and divide. Have I divided yet? No. After I get my factors after creating my t-chart, I now need to divide. What do I divide by? 2. The number I multiplied by earlier, right? My leading coefficient from the original problem. So I got to divide these by 2. Can I simplify 3 over 2 any?
Can we get a base number?
I cannot simplify it anymore. I'm just going to leave it like that for now. Can I simplify 4 over 2?
Yeah.
What's 4 divided by 2?
2.
2. Does anyone remember the last step on slide and divide? Bottoms up. If I have a fraction left, I bring the denominator of that fraction out front in front of my variable. So this will become 2y minus 3 and y minus 2. It is now factored. Everyone okay with slide and divide? Questions there? And if there's 4 terms, most of the time we'll use factoring by grouping. Okay? You guys remember that? Hopefully a little bit. So if I have 4 terms here, let's not worry about the equal 0 yet. If I have 4 terms, what do I need to do?
So separate them.
How do I separate them?
Like, split them down the middle, I guess.
Yeah, so I group the first 2 terms together, the last 2 terms together, right? And now I can pull a GCF out from each of those groups. So let's find a GCF for this first group. V cubed minus 2v squared. What would my GCF be here? Huh?
On which one?
The first group. What's the GCF? What? V squared. The only number that goes into 1 and negative 2 is 1, so I can't pull out a number other than 1. And then they have 2 v's in common, right? So I can factor out a v squared. And now let's get what's in the parentheses. V squared times what would give me v cubed? V. V squared times what would give me negative 2v squared? Negative 2. We okay with that first group?
Yeah. Why are you yelling so loud?
Huh?
Why are you yelling?
I'll make sure everyone can hear me. I'm not meaning to like yell.
You are screaming.
Sorry. Maybe I'll talk a little louder. Okay, the second group. Negative 16v plus 32.
Dude, you did try.
What's the biggest number that goes into negative 16 and 32?
Negative 16.
Okay, negative 16. Do they have any v's in common?
No.
No, they don't.
Did you speak up?
So, my GCF here is negative 16. right? So negative 16 times what would give me negative 16v? V. Negative 16 times what would give me positive 32? Negative 2. We okay with that? I'm not done though yet, am I? What do they both have in common now? V minus 2, right? So that is one of my factors. What's my other factor?
V squared minus 16.
V squared minus 16, my two GCFs that I pulled out, right? So there's my two factors. Is this my final answer? Are you sure?
Yeah. No, it's
Why not?
because you can do things.
Huh?
It's your final answer.
What thing?
The
What thing we're talking about?
Can't you wait? Can't they go down further?
Huh? What about the exponent? How? Well, if I can't factor it any further, this would be my final answer. But can I factor this further?
Yes, the negative 2 and the negative 16.
But you know what I'm talking about.
Difference of squares.
That's what I said.
Can I take the square root of a, or my first term?
Yes.
On this one, can I take the square root of that first term? V squared. Yes. Can I take the square root of 16? Yes. Do they have a subtraction sign between them? Yeah, that's the difference of squares. So I can factor this further. Be careful about that. They like to do that sometimes. They like to trick you. You think you're done by factoring by grouping. And then boom, difference of squares. So, v minus 2, I'm going to bring that down. Then I'm going to create my sets of parentheses for my next factoring. What's the square root of v squared? V. Put a v there and a v there. What's the square root of 16?
4.
Put a 4 here, 4 here. What are the signs going to be?
Negative. Or they're different, right?
One's a plus, one's a minus. Is this now factored all the way? Yes, this is factored completely, right? You okay with that? Last thing real quick. Let's say it asks you to solve an equation by factoring. So they would have shown it like this. They would have given you v cubed minus 2v squared minus 16v plus 32 equals 0. And they would say, solve this equation by factoring. So I factored it, right? And so I get v minus 2 times v plus 4 times v minus 4 equals 0. I factored it. But I still got to solve it. I got to figure out what v equals, right? How would I do that from here? If I distribute all this back out, I would just get back to my original problem. It's a good thought, though. You guys remember the zero product property? You probably remember hearing me say that, but you may not remember what it is, right? So, I've got three things being multiplied together, and they equal 0, right? If that's the case, I know one of them must equal 0, or all of them equal 0. Right? So what I need to do is, I need to set each factor equal to 0 and solve those three equations. So v minus 2 equals 0, v plus 4 equals 0, v minus 4 equals 0. Now I'm just solving these three equations for v. First one, how do I get v by itself? Add 2 to both sides. So what does v equal here? 2. You okay with that? For the next one, how do I get v by itself? Subtract 4 from both sides. What does v equal here? Negative 4. And the last one? Add 4 to both sides. V equals 4. And so that would be my answer, these three numbers. 2, negative 4, and 4. So I solved it by factoring. Okay? If any of these had 0 behind them, I could have solved them by factoring. Factor it like I've been doing. Set it equal to 0 and set each of my factors equal to 0. Solve for the variable. Does that make sense? Yes? Whenever I'm done doing this. Okay? Does that make sense about solving? Now, it's not always going to be set up like this. It could look like v cubed minus 2v squared plus 32 equals 16v. It might look like that, and it might tell me to solve it by graphing, or by factoring, not graphing. What would I have to do here?
Then
What is that?
take it that video that
Very good. I want to get all my terms to the same side, and I want the other side to be 0. That way I can factor it and then solve it by factoring. So I'd subtract 16v. Subtract 16v. v cubed minus 2v squared minus 16v plus 32 equals 0. And then I'd go from there to factoring it and setting them equal to 0. Okay? Questions about that? Questions about my review real quick?
How would you factor? What would be your first step to factor that?
Oh, that's like what we did right here. It's the same exact problem. I just put that 16v over to the right first.
Okay.
So I would group,
Yeah.
pull out GCF of each one, do that difference of squares, and then set each factor equal to 0. Just like we did here. Yes? The notes? Yeah. Yeah, I'm going to put these on Canvas. Are there any questions about anything we just covered? We ready for the assignment?